So the part plus part equals whole idea that we talked about in our warm-up has two fancy names, one for segment, one for angles. So for segments, this is called the segment addition postulate. We often write it down as SAP, so segment addition postulate. And essentially it's talking about if on a line AC, if B is in between A and C, then AB, so the first part, plus BC, the second part, equals AC, the whole thing. So part plus part equals whole. Same thing for our angle addition postulate. If, let's say we have an angle that's split in the middle by a ray, so that's why it says if D is a point in the interior of BAC, so you're imagining it's being split by a ray in the middle, then the measure of angle BAD, or this angle on the bottom, plus the measure of angle DAC, or the angle on the top, equals the measure of the entire angle. So again, part plus part equals whole. We usually write this one down as AAP. Okay, so we're going to use those ideas to solve for some things. I actually bet you guys could try the first one because it was similar to our warm-up, so I'll let you guys work on this one and then we'll check it together. All right, so let's talk about this one. So the first thing I always do is I always label my picture. I think that's a good habit to get in for you too, especially when the problems get more complicated. We do part plus part equals whole. Solve for x. Did you guys get x equals 4? Yes, and then we plug back in. So AB used to be 6 times x plus 5, but now we know what x is. So 6 times 4 plus 5, which would give us 29 units. Okay. So here we have one with an angle. So given that JKL is a right angle, so I'm going to draw a little right angle symbol in there. The measure of angle JKM, so JKM, that's angle 1, is 3x plus 1, so I'm going to label that. And the measure of LKM is 2x plus 4, so I'll measure that. Find the measure of angle LKM in degrees. I'll let you guys try this one too. Okay, let's talk about this one. So, same idea, part plus part equals whole, right? So angle 1 plus angle 2 equals 90. So when we solve for x, we get 17. And then we're just plugging back in. So LKM, when we trace it with your finger, you find out, oh, that's angle 2. So 2 times 17 plus 4 gives you 38 degrees. And make sure you put your little degree symbol on there since it is a degree. All right. Okay, let's look at one that's a little bit more fun to work on. We like things that are interesting. Okay, so the next one. We have B is the midpoint of segment AC. So let's draw our own picture on this one. So go ahead and draw yourself a segment. Let's call it AC. And we know B is the midpoint, so put B in the middle. And let's also show in our picture that it's the midpoint. So let's use our congruency symbols to show that B is in the middle. Because usually if it gives us a piece of information like B is the midpoint, that means we're going to need to use the fact that B is the midpoint. So it's helpful to put it in the picture. All right, and then let's label what we've got. So AC is 100. So the whole thing is 100. I usually just draw a little bracket across the bottom of my segment to remind myself the whole thing's 100. AB is x plus y. And BC is 3x minus 2y. And the goal is to solve for x and for y. Okay, let's see. So if we do our part plus part equals whole equation, that would look like x plus y plus 3x minus 2y equals 100. So that would be doing exactly what we did in the first problem where we do part plus part equals whole. If we simplify, we would have 4x's minus 1y equals 100. But then we're stuck, right? We can't keep solving that equation because we have an x and a y. So in your head, when you see, oh, I have one equation with both an x and a y, that's cueing you that you're going to need to solve a system. Wow, good job, guys. Awesome. Okay, so for a system, that means you need a second equation. So let's go back to the picture and figure out what kind of second equation you could write. I want you to think about one that you could write because you actually have 3 different options, okay? So think about what equation you could write down and talk to your group real quick about what your options are. All right, guys, what's one option that we could write down? Yeah. Okay, yes. So one option would be x plus y equals 50. Option 2 would be 3x minus 2y equals 50. What would option 3 be? What about x plus y equals 3x minus 2y? That would be your option 3. So you only need one of the options, and they're all will get you the same answer. Let's just do x plus y equals 50 because that's one we talked about first. So we'll let our second equation be x plus y equals 50. And look how convenient this is to solve by elimination. If we add these equations together just how they are, 4x plus x is 5x, negative y plus y is 0, so those eliminate, equals 150. Divide by 5 on both sides. So x is 30. And once we have one variable, to get the other one, we can just plug it in. So we'll just go back to any one of our original equations. I'm going to do the x plus y equals 50 because that seems simplest. Plug in a 30 for x, so 30 plus y equals 50. So y is 20. Okay. All right. Questions so far? Okay, so remember for this one, when you see 2 variables, think to yourself, I'm probably going to need 2 equations so I can solve a system. That's the key for this one. All right, next one on the back. We are solving for x on this one. We are given the measure of angle AXB. So this top angle is 3x. The measure of angle BXC, so the bottom angle, is 54. And the measure of AXC, so that's the whole thing, is x squared. So we can do part plus part equals whole. That's the angle addition postulate. So 3x plus 54 equals x squared. Only one variable, so no system is necessary, but we have a regular x and an x squared. That cues you that you're going to need to, somebody say factor. Factor, yeah, okay, good. Okay, so in order to factor, we need to get one side equal to 0. So we're going to bring everything over. I'm going to take it all to the right. I prefer my x squared to be positive. So I'm going to subtract 3x from both sides and subtract 54 from both sides so that I get 0 equals x squared minus 3x minus 54. All right, so when we factor by grouping, we are looking for two numbers that will multiply to our a term, which is an invisible 1, times negative 54. So we need it to multiply to negative 54. It adds to the middle term, so it adds to negative 3. So think about that for a second. What will multiply to negative 54 and add to negative 3? Yeah, 9 and 6. Which one should be negative? The 9, yeah, because we need that negative 3. So when we factor by grouping, we bring our first term down, so we still have x squared. The second term is what gets split into minus 9x plus 6x. The last term comes down, so minus 54. And then it's all still equal to 0. Then we group the first two terms. We factor out what they have in common. These guys have an x in common, so that means we have an x minus 9 left over. We group our second two terms. These guys have a 6 in common, so that means we have a x minus 9 left over. It's important at this step that your parentheses match because we're going to factor those out. So x minus 9 gets factored out. What we're left with is x plus 6. So our two factors are x minus 9 and x plus 6. Okay, so set each one equal to 0, x minus 9 equals 0, x plus 6 equals 0. Gives us that x equals positive 9 or x equals negative 6. Now, just like before, when we have two solutions, we're going to check to see if we have any extraneous solutions. It's possible that both will work, but we need to check them. We're looking for positive measurements and for angles that are less than 180. So if we plug 9 into x squared, we get 81. That's positive, less than 180. That checks out. If we plug 9 into 3x, that's 27. Positive, less than 180. That checks out. So 9 for sure is good. If we plug in negative 6 to x squared, we get positive 36. That checks out. If we plug in negative 6 to 3x, ooh, that's negative 18. So that does not check out. So x minus 6 is not a good solution. So our only good x value is x equals 9. So remember, when you're checking, it is possible to have two solutions, in which case you would report both x values. Also, make sure that you're plugging it into every possible place that there's an x, especially when we're doing ones with a segment and you factor and you get multiple spots, like on a segment that maybe has like 3 different places where x appear. Plug it into every spot because it might be positive measurements for the segment on a couple, but maybe not on the last one. So make sure that you're plugging it in to every spot. That's the most common mistake I see on these. Okay. I'm going to let you guys think about number 5 for a minute and try and problem solve it, and then we'll talk about it together. So the person who's wearing the brightest outfit today gets to read this one out loud. Ready, go.
The two angles that
Oh yeah, I get it. Are you guys set? A little bit? Okay, so let's think about like ratios. For example, like, if you're in the recipe has a ratio of 5 to 7, like flour and sugar, that would mean you have like 5 cups of flour for every 7 cups of sugar. So in that case, like how many total cups would I use that? So if I use 5 cups of flour, instead of just a kind of say 12 total like pieces of the recipe. Here we have 12 total pieces of the meating level. So can you figure out how much each piece is? No, you're putting it into the picture. The zone to work in your equation, because that's where it's in the picture that I'm doing down. So just like right here, like for AXB, so 3 points and angle AXB right. Yeah, because our measurement has
If we get 7x, try to solve that, we get x, we multiply x by 5. And I think you get angle.
Oh, that's because that was when we had elementary, and so our total was 180. Yeah, but in this case, our total is x squared. So 180 doesn't show up as angle and not supplementary. Well, if it's going to have that 180 that I told you, instead of measure AXB equals x squared, it would say measure AXB. Yeah, or it would say supplementary.
I mean, it obviously goes into
There's literally no
All right, guys, let's talk about this one. So ratios can kind of like get confusing, right? So, like if you think about if you're baking, if you had some crazy recipe where the ratio of like flour to sugar was 5 to 7, if I put in 5 cups of flour, how many cups of sugar would I need to match the ratio? 7, right? That's what it means to be in a ratio of 5 to 7. So for every 5 cups of flour, I have 7 cups of sugar. So in that case, how many cups total would I have put in the recipe? 12, right? So 12. So you're imagining that this recipe has 12 total pieces. So same thing for the angle. For angle CAD, which is a smaller angle, we have 5 cups of CAD, or 5 pieces, 5x. That angle is taking up 5x, or 5 cups of the total angle. The other angle, DAB, that's our sugar, it gets 7 cups. So total, we have 5x plus 7x, or 12x cups of our angle, or pieces of our angle. And we know how much is our angle altogether. It's 50, so all of our pieces add up to equal 50. So now we're going to figure out how much one piece is worth. So 12 pieces is 50, so divide by 12 on both sides. Well, we're just going to leave this one as a simplified fraction, so 25 over 6. So that means that each piece of the angle is worth 25/6. Okay, and we want to find angle CAD, which we said is a smaller angle, so that means it has 5 pieces. So it gets 5 of the pieces that are 25/6. which means its angle is 125 over 6 degrees. I'm just going to leave it as a simplified fraction like that instead of converting to a decimal. All right, any questions about this one? All right, one other note before I give you your practice is sometimes it will tell you that two angles are supplementary. So remember, supplementary means it adds to 180. And then the other note that we haven't talked about, I don't think yet, is complementary. Does anybody know what complementary means? Yeah, add to 90. So maybe make yourself a little note. When it says that angles are complementary to each other, it means that your two angles will add to 90. So it's like a sister of supplementary, right? Supplementaries add to 180, complementaries add to 90. So if you see that, that's what it means.